Greetings, traveler. I am the calculus cleric, and today we'll be doing more work on the infinite series. So, to start off this problem, they're asking us to find the sum of the infinite series starting at k equals 2 of 1 over k minus 1 over k plus 1. So, now where do we start? Well, a good way to do this is to find the first sum of the series and then the second sum and the third sum and attempt to find a pattern. That's one way to do it. So what I mean by that is you get the sum of 1, where starting at k equals 1, you just figure out the sum of that. And because it is the first sum, there's nothing before it, so we don't really need to add anything to it, which will give us 1 minus 1 half, which is equal to 1 half. But this is a series, not a sequence, so when you take the second sum, we have to remember to add the previous sum onto this as well. So 1 half plus the value of the second sum, which is 1 half, replacing k with 2, 1 over 2 plus 1, which is equal to half plus 1 half negative 1 third, which is equal to 1 minus 1 third, which is equal to 2 thirds. Third sum, same process as before. So now we can attempt to find a general pattern for this rule. So if we notice the sums, they appear to be going up by a certain value. So there are two ways that I see that we can call our general sum. One way to do this is n over n plus 1. Because if you notice, the first sum is 1 half, second sum is 2 thirds, third sum is 3 fourths. Just to be safe, I'll go calculate the fourth sum in the corner. Yes, it works out. This is one of the possible sums that we can use, or we could go with this one as well, because if we see this previous pattern, there's also a pattern there. 1 minus 1 over n plus 1. So these are the two s of n's available for us to use. And basically, to solve this problem, we have to take the limit of infinity of s of n, because that is the definition of that. The r's would probably look something like this. And from here, we now have to find the limit of infinity of s of n. I will solve both s of n's out for you. This would require L'Hopital's rule, because infinity over infinity is undefined. Taking the derivative of the top and bottom yields you the value of 1. Doing it with the other term, the other sum, which is 1 minus 1 over n plus 1, that's infinity. 1 over infinity is 0, so 1 minus 0 is 1. So you see we get the same values for both of those general equations. So as you can see, there can be multiple general equations for a single sum, although I suppose they really are just the same series. 1 minus 1 over n plus 1 is just equal to n over n plus 1 if you turn it all into a common denominator and add them together. So from here, we have figured out that the sum of k equals 1 over 1 minus k minus 1 minus k plus 1 is equal to 1. Okay, now wait a minute. Why is this k equals 2 and this is k equals 1? Well, because for this value, we started at the sum of s of 1, and we incorporated that into our answer, calling it part of our series. But because this starts at k is equal to 2, it means they want to start the series at s of 2 rather than s of 1. And so if we did it like this, what we're going to have to do now is take out the value of the first sum, the first term, to get us to the second term. And so figuring out the first term, it was 1/2. So basically what we do to change this to that is we just subtract 1/2, which gives us 1/2 as our total sum. This will be equal to that